The overall goal of this procedure is to offer a straightforward strategy for grafting multi-walled carbon nanotubes by polystyrene chains, which mediate supramolecular self-assembly and anisotropic patchiness.
This method can help to modulate the surface properties of multi-walled carbon nanotubes so as to establish improved processing conditions of the same in the field of thermoplastic polymers. The grafting strategy offers a straightforward alternative in processing protocols for carbon nanotubes in order to compatibilize them with industrially relevant yet challenging polymers such as polystyrene. In general, the method starts with the introduction of hydroxyl groups on the side walls of pristine carbon nanotubes, followed by the coupling of silylated methacrylic moieties to the OH groups, and their sequential free radical polymerization with styrene under inert atmosphere to finally yield nanotubes grafted with polystyrene chains.
The main advantage of this technique is that it can be easily deployed to modulate surface properties of carbon nanotubes and consequently promote their anisotropic self-assembly, which in turn may facilitate their inclusion in a polymer matrix. This technique opens promising alternatives to improve the supply chain of nanostructured carbon allotropes in industrial processes, thus allowing for the creation of electrical percolation networks in polymer composites which could find direct applications in electromagnetic shielding systems, mechanically reinforced parts, and electrically conducting materials under attractive cost-benefit conditions.